Okay, dependent and independent probability work. So that's when there's two different things that you're comparing the probability to. So a number cube is rolled and the spinner is spun. Determine the probability of rolling a 1 on the dice and landing on A on the spinner. So on our dice, or on the cube, it's got 6 sides. So we have a 6-sided die. And the probability of landing on a 1, think about how many of the sides have the number 1 on it. It's just 1 because it's numbered 1 through 6. And then on our spinner, we have A, B, C, and D. So there's 4 total sides. And then the probability of landing on the A is just 1 out of 4 because there's only one A. Okay, so now that we have our 2 different probabilities, we want to multiply these together. And so what that looks like is we line them up side by side, 1/6 times 1/4. So we just multiply across. 1 times 1 is 1, 6 times 4 is 24. So 1 out of 24 is our probability. Same thing on the next one. We still have a dice, so that's out of 6, and we still have a 4-sided spinner, so that's out of 4. So then it says determine the probability of landing on an odd number. So if we have our dice, think about how many numbers there are on it. We've got numbered from 1, 2, 3, 4, 5, and 6. So how many odd numbers are on a dice, or on a die, excuse me. There's 1, 3, and 5. So 3 of the numbers are odd. And we can go ahead and reduce that if you can see that easy, because that will make your multiplying a lot easier. So 3/6 can reduce down to 1/2 or 1/2. Now on the spinner, there's 4 sides, and the probability of landing on B, there's just one B, so that would be 1/4. And same thing, we're going to multiply these two together. So 1/2 times 1/4. And you just multiply across. 1 times 1, 2 times 4. Okay, again, out of 6, out of 4. And the probability of a prime number. So I messed this up earlier, but 1, 2, 3, 4, 5, and 6. So our prime numbers are going to be 2, 3, and 5. 1 does not count. So that would be 3 out of 6, or 1/2. And landing on D, again, would be 1/4. So 1/2 times 1/4. The number cube is rolled. Here we go again. So out of 6, out of 4. So the probability on the dice of a number greater than 4. If it helps every time to write the numbers that are on the dice, then you can totally do that. The number's greater than 4, so that doesn't include 4. That just means bigger than 4. So that's only these 2. So 2 sides out of the 6 are greater than 4. And C, there's one C. If you want, you can reduce that to 2/6. So, and we can do that by saying both of these can be divided by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. So that gives me 1/3 for the dice times 1/4. So 1/12. Again, we have a cube out of 6. We have a spinner out of 4. So less than 3. 1, 2, 3, 4, 5, and 6. Less than 3. It doesn't say 3 and below. It says less than. So that would only be 2 of those numbers. And remember, we can reduce. We need to reduce, actually, not just can. And a consonant. So think back to elementary English. Consonants and vowels make up the alphabet. Our vowels are the A, E, I, O, U. Consonants, everything else. So on the spinner, the consonants would be B, C, and D. So that would be 3 out of 4. And we're going to multiply. So 1/3 times 3/4, and we just multiply across. So 1 times 3 is 3, 3 times 4 is 12, and that's not an answer choice, and I know that I can reduce that. So 3 can go into 12. So I'm just going to divide both top and bottom by 3. 3 divided by 3 is 1, 12 divided by 3 is 4. Okay, same thing, out of 6 and out of 4, 1, 2, 3, 4, 5, 6. Your prime numbers, 2, 3, 5. So that's 3 out of 6, or 1/2. And a consonant, so just like the last one, our consonants are B, C, and D. And we're gonna multiply these two and then reduce if you need to reduce. Uh-oh, I might have been skipping numbers. I don't know. Each spinner below is spun once. Determine the probability of landing on A and 2. Okay, so let's look at both of these spinners, and we want to count our totals. So on spinner 1, my total is 1, 2, 3, 4, 5. So that's going to go on the bottom of my fraction. I guess I'll do it like this. And spinner 2, I've got 1, 2, 3, 4, 5, 6 on spinner 2. And the probability of landing on an A on spinner 1 is 1, because there's only one A. The probability of landing on a 2 on spinner 2 is 2 out of 6, because there are 2 2s. And then we want to put those together. So let's say 1/5 times 2 6, but I think I can make this smaller, and I'm going to divide those two numbers by 2. I know they can both be divided by 2. So 2 divided by 2 is 1, 6 divided by 2 is 3, so it's actually times 1/3. 1 times 1 is 1, 5 times 3 is 15. Okay, same thing on these. Spinner 1 has 1, 2, 3, 4, 5, so that's my bottom number. Spinner 2, 1, 2, 3, 4, 5, 6. And it's asking for the probability of a vowel, so that's A, E, I, O, U. So spinner 1 has an A and it has an E. So that would be 2 out of 5. And on spinner 2, the probability of an even number. So that would be 2, 2, 4. Okay, so 3 out of 6, which we know can reduce down to be, oh my gosh, 1/2. Okay, and with those two fractions, those two probabilities, we're going to multiply those together. So 2/5 times 1/2. 2 times 1 is 2, 5 times 2 is 10. Okay, and we can reduce this one more time. 2 can go into 10, so we're going to reduce them both by 2. 2 divided by 2 is 1, 10 divided by 2 is 5. Same thing on spinner 9, or question 9. 1, 2, 3, 4, 5 is my bottom number because it's the total amount. 1, 2, 3, 4, 5, 6 is the total amount. 1, how many 1s are there? On spinner 2, consonants, that would be your B. Whoop, thought I was on highlighter mode. That would be B, C, and D. Put those together and then multiply. Okay, same things. These are the same spinners. So we're looking at out of 5 and out of 6. Probability of landing on D and a number greater than 1 on spinner 2. So that would be all of those. All of those are greater than 1, and then multiply across. Okay, question 11 is a little different. There are 3 red, 1 blue, 2 yellow marbles in a bag. 1 marble is selected. It is not replaced. Okay, so that means we're going to do this twice, and we're not putting 1 back. So that means our total is going to change. So determine the probability of a red, pulling out a red, and then a yellow. So the first time we pull 1 out is for the red. how many total do we have? We've got 3 plus 1 plus 2. So that would be 6 altogether. So the first time we pull one out, there's 6 altogether, and we're trying to find a red. So there are 3 red, so there's 3 possibilities. Okay, the second time, we didn't put that red marble back. We pulled 1 out, and we didn't put it back. So I took 1 away from that total of 6, and now my total is 5. Now what's the probability of it being a yellow? I still have all my yellows, so that would be 2. 2 out of 5. Okay, reduce if you can, multiply across. Question 12 is the same. There's 3 red, 1 blue, 2 yellow. Once a marble is selected, it's not replaced. So it's going to be just like this one where our total changes. Determine the probability of pulling out a blue and then a yellow. So I have 3, 4, 5, 6 at first. I pull 1 out and I don't put it back. So that means the second time I do it, there's only 5. So the first time, what's the probability of pulling a blue marble out? 1 out of 6, because there's only 1 blue. And then the second time, a yellow. Well, there's 2 yellows, so there's a probability of pulling 2 yellow out. Multiply across and reduce. Okay, same thing. Out of 6, it's not replaced. So the next time I do it, there's only 5. Probability of red and then blue. So the first time, there's 3 red, which is really just 1/2. And then the second time, I pull a blue, and there's only 1 of those. It's the only possibility. Oop. So 6 and then 5, 2 yellow marbles. So the first time I reach in and I grab a I grab a marble and we want to see if it's yellow, there's 2 possibilities. It could be one of the 2. Okay, well, if the first time I pull a yellow out, now one of my yellows is gone. Okay, so the second time I reach in, there is only 1 yellow left. Okay, blue cards, same thing. Oh, but this is different. This is a different total, so sorry. 3 yellow, 6 blue, 5 red, and 2 green. So let's see, 6, 11, 12, 13, 14, 15, 16. Once a card is drawn, it's not replaced. So again, if we want 2 cards, the next time I draw a card, it's going to be 1 less because I didn't put that card back. So the probability of 2 blue cards. So we start out with 6 cards. And if that's the card we draw and we don't put it back, then now the second time I reach in, I only have 5 blue cards. And these numbers can be reduced. Let's divide this by 2. That's the only thing I can think of right now. So 3/8. This can be divided by 5. So 1/3. Okay, same thing. 3 plus 6 plus 5 plus 2 gives us our total. If it's not replaced, that means our total is going to go down 1 after we pull 1 card out. So 11, 12, 13, 14, 15, 16. The next time will be a 15. And 2 red cards. So if we start with 5 the first time, the next time will have to be 4. Okay, the next couple are the exact same. They're not replaced. A yellow card, then a red card on 17. A blue card, then a green card